Good day everyone, this is our video explaining the DES Cipher internals. Before continuing the video, I want to introduce myself first. Hello everyone, I am Lakela Jerome de la Cruz and this is our video. Convert to bits. DES works on bits or binary numbers at the zeros and ones, common to digital computers. Each group of 4 bits make up hexadecimal or base 16 number. Binary 0001 is equal to hexadecimal number 1. And binary 1000 is equal to hexadecimal number 8. So I will give you some example. Example number 1. Plain text is 1. If we convert it into bits, it will become a 0001. Next one, plain text. If the plain text is 2, if we convert it into bits, it will become 0010. And so on and so forth until we go to plain text number 8. If we convert it into bits, it will become a 1000. This works by encrypting groups of 64 message bits, which is the same as 16 hexadecimal numbers. To do the encryption, DES users keys are also apparently 16 hexadecimal numbers long, or approximately 64 bits long. However, every 8 keys, bit is ignored in the DES algorithm, so that the effective key size is 56 bits, but in any case, 64 bits. 16 hexadecimal digits is the round number upon which DES is organized. The next one is initial permutation. In applying initial permutation, we need to follow the procedure. That means we need to follow the transposition order. DES is a block cipher, meaning it operates on plain text blocks of a given size, which is 64 bits, and returns cipher blocks of the same size. Thus, DES result in a permutation among the 2 to the 64th power possible arrangement of 64 bits, each of which may be either 0 or 1. Each block of 64 bits is divided into 2 blocks of 32 bits each. A left half block or L and a right half block. This division is only used in a certain operation. So I will give you some example. Let M be the plain text message. If M is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, where M is an hexadecimal base 16 format. Rewriting M in binary format, we got a 64-bit block of text. So, as you can see on the PowerPoint, here are the plain text that convert into a bits. So, the first bit of M is 0 and the last bit is 1. We read from left to right. Next is expand right. When we say expand right, we need to input the expansion permutation. And it means you have to expand the number of bits. We need to follow that transportation order for the expansion permutation. The table shows we need to arrange 1 to 32 bits and the 16 bits will be added so that the complete bits is 48, because the input permutation is 32 bits and the output permutation is 48 bits. So we are adding the 16 bits.
The XOR or exclusive OR gate acts in the same way as the logical either or. The output is true if either but not both of the inputs are true. The output is false if both inputs are false, or if both inputs are true. Another way of looking at the circuit is to observe that the output is 1 if the inputs are different but 0 if the inputs are the same. A substitution box or S-box is the lone component in one crypto system that gives rise to a nonlinear mapping between inputs and outputs, thus providing confusion in data. An S-box that processes high nonlinearity and low linear and differential probability is considered cryptographically secure. The substitutions are performed by 8 substitution boxes or S boxes. Each S boxes has 6-bit input and 4-bit output, and there are 8 different S boxes. The total memory requirement for 8 S boxes is 256 bytes. The 48 bits are divided into 8 6-bit sub-blocks. Permutation. So this is same in substitution, but permutation uses the plaintext message letters but rearrange their orders, while substitution replace plaintext letters or strings of letters by letters or number or symbols.
XOR left. XOR is also used to detect an overflow in the result of a signed binary arithmetic operation. If the almost retained bit of the result is not the same as the infinite number of digits to the left, then that means overflow occurred. XORing those two bits will give a 1 if there is an overflow. Next is rotate halves left 1. Circular bit rotation is an operation where bits are moved in circular fashion such that bits change their positional values. Rotation operation is where bits that fall off the left end are placed back at the right end. And the last is the extract bits. Example here is input number equals 171 and the K is 5 and the N is 2. The output is the extracted number 21 and 171 is represented as 0101011 in binary.